My name is Tim Shea. I'm a senior analyst at ARC, and I'll be talking a little bit about highlights about leveraging smart field systems to create value. And we originally kind of coined this in process industries, but we kind of, I guess you could, you could really create value with smart field systems across many industries. So with that, I'll begin. Just some high-level talking points here about, from my perspective, that smart devices, they really are a powerful tool to provide operators and end users operational visibility, flexibility, and agility in their operations. And we'll talk about a little bit more about, you're seeing a lot of talk about IoT and analytics, and one of the things we believe in is that, sensor data can be transformed into actionable information and for decision-making and tactical and strategic purposes. Just a quick snippet. Again, I'm going to try to go through these slides pretty quickly, so if you, again, you don't want to wait for a couple weeks to get the email, you can come up to me after the session. I'll be happy to send you a copy of the presentation, but I kind of want to get through it so we have time for our two great speakers here. But these are just some basic examples of what I put up there as to some of the types of devices that we would call perhaps smart field systems or smart field devices. Obviously, enhanced communication networks. We're seeing increasingly Ethernet moving down into the field level. Obviously, wireless HART, ISA 100, proprietary networks are playing a role. Obviously, primarily in monitoring at this time. And the key is to, the access to real-time data. Again, to be able to just don't have the data to sit there, but you want to be able to act on it. Oops, excuse me, I went a little too fast. And we're, based on our research over the years, we've seen that there's still a nagging problem or a challenge, if you will, about a lot of the issue of stranded data. There's a lot of smart field devices out there, but we find that the amount of stranded data is still pretty high, and that's a function of, we think, of a couple of factors. Work processes, maybe, perhaps cultural. There's a few things that we think will play a role, but basically we're trying to say that there's a tremendous amount of opportunity to leverage the sensor data that's being acquired today. And intelligent device management, in my mind, is about risk management, risk mitigation, if you will. That can be operational, that can be financial, and any kind of financial, obviously. So there's a lot of critical needs, not just tactical, but also somewhat, in some cases, strategic issues at hand in terms of being able to better manage your device and the data that's derived. Here's just a quick summary of some of what we believe are some of the economic paybacks. Obviously, the big issue you've heard about already during this forum is the issue of unplanned downtime, which, depending on the industries, can be a bane of many operators and management's issues. Obviously, increasing workforce efficiency, especially with the great crew change, and particularly if you're in the oil and gas industry, you know about the huge number of layoffs. 3, 4, 500,000 people, depending on what numbers you see, and some of those folks are just not going to come back into the industry. So, being able to work with leaner workforces, and particularly those that are coming in that are millennials that may not be gray-hairs, that have some of that domain expertise, and what's the challenge, and how can managing sensor data and workflow and work processes help mitigate some of that. I wanted to just put a little bit of a ISA 100 in there in case you haven't familiar with it. It's a standard, kind of focuses on, again, intelligent device management, and I think we had a guy, Herman Story, who presented here 3 or 4 years ago at my session that had really drilled down into what they're doing in ISA 108, and I certainly applaud you to at least to take a look at that and see how it might perhaps apply to some of your operations. But basically, it's about using the sensor data to really empower the employee, to empower management through greater visibility and information that can be acted on and not just sit stranded, if you will. Just a quick premise. Again, this might be one you want to take a look at offline. Is what we see as some of the main components of industrial IoT. You've got obviously your assets, your devices, your products, your machines, and that's to make that work. You need communications and network infrastructure. You obviously need analytics, and you need software to make the data mean something and to be actionable. And I look at it as, if you look down here in the bottom, the sensors really, in my mind, and it'll come up in another slide, is really, I look at that as the tip of the spear. I mean, without good, reliable sensor data, IoT is the full impacts of IoT are mitigated. And most importantly, it's, as I've been telling people that I talk to, is that it's not just the technology, it's about people, processes, and systems, and most importantly, I think, culture. And I think that was talked a little bit about in some of the keynotes over the last day or two. Based on some of our research, this is some of the reasons why we see people really starting to embrace IoT. Obviously, the big ones are things like unplanned downtime, increasing service response, particularly by the OEMs, enhancing employee productivity, and in my mind, not just making the existing workforce more productive, but empowering the next generation of millennials that will be taking over in that regards. Obviously, asset life cycle management, predictive maintenance, things like that. Those are very much the lowest hanging fruit in my mind, is really rotating equipment, and the higher the dollar value asset, the greater the need for the IoT and the analytics in that regards. Again, as I talked about, I believe that IoT and sensors and smart field devices is really a match made in heaven in my mind, because I believe, again, that's sensors and particularly smart field devices are the tip of the spear in terms of driving a lot of the data that can be acted on through the enhanced communications, through some of the advanced analytics, and hopefully through some cultural and work process changes that will be, I think, required to fully maximize the benefit in this area. This is a little bit of highlights about some research we've done over the last several years on multi-phase flow metering. We're seeing it increasingly a growing area in the oil and gas space. There's also some use in some other industries like pharmaceuticals and others. And we found that the biggest inhibitor was the actual testing and validation of the units, because different formations have different porosity, organic contents, a number of different factors that can make a flow meter successful in one formation not necessarily be as successful in another formation. So companies like Emerson and ABB and Schlumberger and a number of companies have actually invested millions of dollars in building their own testing facilities to try to address that issue. And I think we just saw recently that NEL is going to be trying to work on an international standard in this area. So I think that is going to be very helpful in trying to improve adoption of these solutions. And they're really multi-sensorial. I mean, they can be gamma ray based solutions with you're talking about Venturi, and it could be a number of different sensors employed. And basically the two main types we found were basically radioactive and non-radioactive. And obviously for a lot of applications, the desire for non-radioactive solutions is increasing, but they have challenges when you start getting into certain gas volume fractions, into certain formation envelopes in terms of the mix, the composite of what's being measured. Leak detection, again, this is sort of based on some research we've done over the last several years, and we focused on basically there's a whole sort of a software, or what they call an internal-based leak detection system, and that's various software packages. But for this purpose of this discussion, we're talking about the various external-based or sensor-based systems, fiber optics, acoustics, hydrogen sensing cables, and the like. And in terms of fiber optics, and particularly ultrasonic, we're seeing applications not just in leak detection, but also fiber optics in well optimization. You're seeing ultrasonics being used in structural integrity, corrosion monitoring, and things like that. So there's a number of good applications for these different types of sensor technologies. And the main goal of leak detection is really risk mitigation. Obviously, in some cases, you have regulatory requirements that you need to meet, particularly in Germany. They have mandating at least one internal system and also an external system. And we see, particularly in the high consequence areas, that may be environmental areas or areas that are near a greater public population, the use of technologies like fiber optics, because of the ability to not only quickly detect the leak, but also to really localize it within plus or minus a meter or two in some cases. And then this is just kind of a quick synopsis about, multivariable transmitters, and then you're obviously talking about pressure flow and some other metrics and things like that. And we're seeing, obviously a desire for those in a number of process industries. And, it saves money, saves the form factor is more attractive, and also it reduces the number of process penetrations. And we're, again, the increasing use of not just the field buses, but also moving up into the Ethernet application layer protocols at Ethernet IP, Profinet, Modbus TCP, and some others is helping to, again, that's allowing a greater flow of information, again, to hopefully be acted on through the analytics that might be employed by various companies to turn that sensor data into actionable information, because there's a tremendous amount. If you look at oil and gas, I look at oil and gas as big data before big data was big data. And I think their challenge is not only using the data within certain operational, like drilling or production or reservoir, but their biggest challenge is in integrating all that data across the whole value chain. And I think that there's tremendous amount of opportunity that'll be employed. So with that, I'll wrap it up, and I'll